Okay, so I believe that this is the monster in form. I'm not quite totally sure that it's the organization, but I gotta be close. Starting here, I'm gonna still have to go through and rewatch all this. The last couple of days, I've just been plowing through this stuff, and when I say plowing through it, I'm talking Lucy's car. Like, I might have watched these videos 2 or 3 times back to back. And I know what you're thinking. Well, Jordan, that's a lot of time, especially in an hour-long video. And yeah, I know. It feels like all that, especially when you come in here. You get that head rush for mathematics. I don't know if you've ever done it. This will do it. You sit back and watch nothing but this stuff for, short of coffee breaks and eating something. Set theory is a monster. Um, I was just picking orders. I can still move things around up in here before, I'm sure. But I want to start with something basic before we get into transforming matrix, and then a couple of different variables on it, because the way that those were presented in those videos, they're good independently, but they're missing this backer of that set theory, and then y in rotation to the figure 4a set natural numbers, b set natural numbers. The way it works like this, when you explain it like that, when we're doing Schrodinger's and other stuff. And I'm doing it a bit of a catch-all, because with that material, you don't necessarily need this. There, it's kind of intuitive that once you start in patterns like this, especially in set theory where it's A, B, and C, that's a logical process where you watch it do what this stuff does, but it's not doing it in sense of something like hydrogen or sunshine. It is doing it in a very different place that doesn't really exist. If possible, it would be the quark states, and it's only because those quark states still do what the proton, neutron, and electron do, but they do it at a different, basically UV or infrared levels to our visible light spectrum of how you quantify that probability distribution. Like, if you get all those states done, and say your board factory is good like that it's a natural number, or it's a set of natural numbers, it's an identity vector, it's a very rigorous process of going through the machine and making sure that you not only did all the reactions, but you did all the reactions in form. See, Z is not a complex conjugative in this set. It's actually a bracketed identity value. But in order to do that, I might need to square it. It's that other variance on that X and Y. Or instead of being squared, it's an irrational value here, which kind of lets it be Kepler and obloid, which makes more sense, even though Earth's orbit is circular, or the Hofmann transfer is good, as those are identity vectors, and it's very confusing and messy, and it's a pain in the butt. But again, let's start back. Set theory, matrix transformation, rotation, because when we get into the trig, it'll do this. And essentially, that matrix rotation is me always doing this. It will bang 0 1 or 1 0, because it's on a positive side. So this would be negative 1 0. This would be 1 0. This would be 0 1, and this would be 1 0. And that's an easy thing to remember when you do it like this, because it's always going R. And in this case, River number, or R naught, is an example of the electron, the proton, or the electron, neutron, proton, Earth, and sunshine, as far as being a radiating body, right? Because Betelgeuse, right? And some scientists will go, well, what about Betelgeuse in your ideal model, Dirac? It's fluffy, it makes for problems all the time. So I thought a cool way to do this, instead of starting with stuff like this, would be a cool way to start this it's an if else and elf and else process, because then you get an alpha transition. It's basically if is the proton, else is the neutron, and else is the electron when it triggers the certain value of what it's supposed to do. They're not by voltage. It's not a physical mechanical process. It's that imp current by virtue of the signal in its letter first, not its voltage, or inverted backwards first. And I thought that's a cool thing. And again, I'm just blowing through this. I'm missing a lot of bullet points to it. So then we're getting back into the geometry, right? I want to get us back into, we did some math, and we're getting into some of the quirky natures of what that if and else v1 and v2 are going to equal inside here, especially when we get over here to escape velocity. It's going to idealize it in a homogenized state where it's not nature. It's not even a mathematical guarantee because we're in different scales. It doesn't necessarily work which science or theoretical versus experimental is theta range. It's basically this right here, a range of divergence, which is mass defect. Because of what mass defect is. So we're going to keep going that. And this kind of like is a step theory of how to determine its an escape velocity to get out of the nature of this problem. How much hydrogen and oxygen molecules in a closed pressurized system will you need to get past all of this by its burn? And so if people had listened to Schrodinger's and stuff before, they're going to be like oxygen and nitrogen atoms in your way. It's going to cause a problem from out here in the way very weakly that air resistance on a rocket taking off is going to be a problem, especially in this here Hohmann transfer. About how we're going to explain that to light, or specifically in our case, define the measurements instead of a satellite to scales that are equivalent to Earth but correlate to the size or to the values of the sun, because the sun is in set theory or in Kepler going to keep some oblong orbit. Our tilt is going to change it. We get winter, so we get white shifted from space. There's more white surface on space. It's a change in some way, and that changes a lot of things. Heat, in this K or I or Y for some reason. And that's a very prevalent mathematics. It makes it real easy. You can see it. There's a value change, but it doesn't soft max through the process like actual summer-winter tilts. So it's important to understand it that way as far as that spectrum. First green, or I might be changing some very subtle things about what it is. Maybe it's orientation to the rocket and or the cannonball, so I can do orbitals and stuff like that. Where is that here? Somewhere in here he does the cannon. I forget which one it is. But we'll go through Kepler's laws as well, bring it back around. And again, I might be changing some organization here. I have to read it through, go do all of them, because I was doing a bunch of other ones with it. And I've kind of picked the choice. And now that they're in a bunch of different forms like this, they're all math, remember. But they're in a bunch of different forms. How do I then condense them down into a 3x5 inch notebook? Right? So I'm going to be chewing on this. I was kind of hoping to get started writing on it today, but I don't want to rush this. So